Hello friends, welcome back to my YouTube channel. Today we will discuss about singly linked list. But before starting the video, I request all of you to subscribe my channel and press the bell icon to get latest notifications. Okay guys, singly linked list is also known as one-way chain, which is defined as the collection of ordered set of elements. Singly linked list can be traversed only in one direction, or we can say that each node contains only next pointer. Therefore, we cannot traverse the list in reverse direction. Now, look at some operations on singly linked list. First, insertion at head. For this operation, we have to make a new node. Say new. Now, news next will point to the head's next node, and head's next will point to the new node. At last, head is also point to the new node, and then set null to the new. If we talk about the complexity of this operation, then we have observed that all the operations that we have performed to add a new node at the head are done in a constant time. Therefore, the time complexity of insertion at head is big of 1. Second operation is insertion at tail or at the end of the linked list. For this operation, we have to reach at the end node of the linked list. Now, create a new node. Set the next pointer of new to null, and temps next will point to a new node. If we discuss about the time complexity of this operation, then we observe that we have to traverse at the end of the linked list. So the time complexity will be big of n. We can reduce this time complexity by taking the tail pointer. Have a look at this. Here we do not have to reach to the end of the linked list. Now just create a new node, set its next to null, temps next will point to a new node, and tail also point to new node, and at last set new to null. The time complexity will reduce to big of 1. Now the third operation is insertion at position. This is quite complex. Let we want to insert the node at nth position, then we have to reach at n-1th position using temporary pointer. Now create a new node. News next will point to the temps next node, and temps next will point to the new node, and at last set a new and temp to null. Now talk about the complexity. So it is very simple. We have to traverse the linked list to n-1th position. Therefore the time complexity will be big of n. Now we'll discuss about the deletion operations. First, look at deletion at head. This is simple. Take a temp pointer, points to head, shift the head to head's next node, and then just delete the temp node and set temp to null. The time complexity for this operation will be big of 1. For deletion at tail, we have to reach at the second last position, whether we have tail or not. Now consider temp at second last, so tail will point to temp and temp will point to temps next. Now delete the temp node and set temp and temps next to null. Time complexity for this is big of n. At last, deletion at position. For this we have to reach at the node which we have to delete, and also to the previous of that node. Consider temp will point the node which we have to delete, and temp1 will point previous of that node. Now temp1 will point to temp's next node, and now delete the temp node and then set temp and temp1 to null. So guys, this is all for today. I hope you will like this video. In my next video we will discuss about the doubly linked list. Till then I will leave this question for you. Comment your answers.